Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. See the next topic, Enthalpy of Solution. The enthalpy change when 1 mole of a substance is dissolved in a specified amount of solvent is called enthalpy of solution. Take 1 mole of the substance and dissolve that one in a particular amount of the solvent, then enthalpy change is called enthalpy of solution, represented by delta solution H naught. This is enthalpy of the solution symbol. The enthalpy of solution of AB, that means a solid substance AB, delta SOL H naught in water is therefore determined by the selective values of the lattice enthalpy and enthalpy of hydration of ions. So enthalpy of the solution equal to lattice enthalpy plus hydration enthalpy. See this, the dissolution of a solid substance AB we can represent in this diagrammatic manner. Solid substance AB is added to the particular amount of the water. Here solvent is water. Then this substance dissolves in that water and produces A plus and B minus ion in solution state, aqueous state. So a solid substance is converted to its ions in aqueous solution. The enthalpy change is called enthalpy of the solution. When this solid is dissolved in water, it undergoes two types of changes. One is, we need two types of enthalpies. One is lattice enthalpy, another one is hydration enthalpy. Now see this lattice enthalpy. For most of the ionic compounds, enthalpy of the solution is positive and the dissociation process is endothermic. Therefore, the solubility of most of these salts in water increases with rise of temperature. Many ionic compounds are dissolved in water by absorbing heat energy. If we increase the heat energy, then most of these salts are soluble. That's why the dissolution of ionic compounds in water is endothermic process. If we raise the temperature, solubility of ionic compounds in water increases. Now see the lattice enthalpy. The lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of an ionic compound dissociates into its ions in gaseous state. 1 mole of ionic compound is converted to its ions in gaseous state, then enthalpy change is called lattice enthalpy. Example, NaCl present in solid state is converted to Na plus and Cl minus ions in gaseous state. Related enthalpy is called lattice enthalpy. So for this, lattice enthalpy value plus 788 kilojoule per mole. Suppose this lattice enthalpy is very high, then what happened? That dissociation cannot be possible. So dissociation of the compound may not take place. Lattice enthalpy means the energy required. Already in chemical bond chapter we completed, the energy required to break 1 mole of the bonds into its atoms is called lattice enthalpy. Here also same thing. 1 mole of ionic compound is converted into its ions means bonds present in 1 mole of ionic compound are broken or not? Yes, broken. So very high value of lattice enthalpy means very high amount of energy is required to break the bonds present in 1 mole of the compound. So lattice enthalpy value very high means dissolution possible? No, that is not possible. Here we mentioned same thing. Lattice enthalpy is very high. The dissociation of the compound may not take place at all. Example, fluorides. Metallic fluorides or HF, these type of fluorides are less soluble than chlorides because fluorine can form strong bond than chlorine since its atomic size is less. So lattice enthalpy of fluorides is greater than chlorides. That's why solubility of fluorides is less than chlorides. Next, it is impossible to determine lattice enthalpies directly by experiment. We use an indirect method. By the direct method, we cannot determine lattice enthalpy. So to determine this lattice enthalpy, we construct an enthalpy diagram that is called Born-Haber cycle. Two scientists developed this Born-Haber cycle to calculate the lattice enthalpy of ionic compounds. Next, enthalpy of hydration. What is enthalpy of hydration? The enthalpy change accompanying the hydration of the 1 mole of an anhydrous salt by combining with specific number of moles of water. An anhydrous salt is combining with particular number of moles of water, then the enthalpy change is called hydration enthalpy. Otherwise, we can define in another way. Enthalpy of hydration is given out during hydration of ions. See this, NaCl is added to the water. Then Na plus Cl minus ions are produced. Those ions are surrounded by water molecules because here solvent is water. Those water molecules can surround Na plus ions and Cl minus ions. Due to this, some energy is released that is called enthalpy of hydration. That is nothing but hydration of ions of a particular compound. So, enthalpy of hydration is always negative. Enthalpy of hydration is a exothermic process, so its value always negative. See the example, CuSO4 present in solid form. That is anhydrous CuSO4 plus 5H2O gives rise to CuSO4 5H2O. In this, hydration enthalpy is minus 78.2 kilojoule. This much amount of energy is released when water molecules are surrounding this anhydrous salt. Now, based upon this enthalpy of hydration, lattice enthalpy, we can decide enthalpy of the solution. So lattice enthalpy is more, dissolution is not possible. Hydration enthalpy is more, then dissolution is possible. Next, see the numericals. Anhydrous AlCl3 is covalent. From the data given below, predict whether it would remain covalent or become ionic in aqueous solution. Ionization energy of aluminium equal to 5137 kilojoule per mole. Hydration enthalpy for aluminium ion Al3 plus is minus 4665 kilojoule per mole. Hydration enthalpy for Cl minus ion minus 381 kilojoule per mole. Okay. So in anhydrous form it is covalent, but in aqueous solution state, what is the nature of AlCl3? We should find out. If AlCl3 is present in ionic state in aqueous solution, suppose if it is ionic in aqueous solution, then standard enthalpy of formation of Al3 plus and 3 chloride ions is. So for these two ions, hydration enthalpies, if we add, then we can get enthalpy of hydration. So one aluminium ion is present, that's why minus 4665 plus 3 into minus 381, because 3 chloride ions are present in 1 mole of AlCl in 1 AlCl3. So total enthalpy of hydration is minus 5808 kilojoule per mole. Now given ionization energy of aluminium, how much? 5137 kilojoule per mole. Here hydration enthalpy of AlCl3 greater than ionization energy of aluminium. Hence, AlCl3 would be ionic in nature. That means after formation of Al3 plus and Cl minus ions, more amount those ions are surrounded by water molecules and more energy is released than ionization energy of aluminum. That's why these ions remains in ionic form in aqueous solution. So answer is option A. Okay students, we'll meet you in the next class.